Hi, welcome to the class. Today we'll understand about different forms of energies, and in this we have the first type of energy, which is mechanical energy, and the symbol for the mechanical energy is E. So energy due to its any body is there, so the energy which is possessed by this body due to its state of rest or motion. So either the object is at rest or it is in a state of motion. So the energy possessed by that object because of its state of rest or motion is known as mechanical energy. So this mechanical energy, which is E, has two different forms. One is potential energy, which is U, and another is kinetic energy, which is K. So potential energy, so we'll first focus on potential energy. So how do we define this potential energy? So this potential energy is the energy possessed by any object by virtue of its or by position or configuration. So any object which is at some position, like we have the fan which is fixed to the ceiling, so it has got some position from the ground level. So this is known as potential energy, or any configuration. So if you take a rubber band and you stretch it, so there is a configuration, change in the configuration. So the energy possessed by the rubber band, if you leave the rubber band, the energy possessed by the rubber band will be the potential energy. So this is the potential energy, and this is how we define it. Now potential energy has two types. What are they? One is gravitational potential energy, another is elastic potential energy. So as I discussed with you, like the fan which is fixed to the ceiling, so it has some position from the ground level. So gravity is pulling it down. Okay, so in that case the energy which is there in the fan is the potential energy, because it is due to some position from the ground level, and the force of attraction is always being applied on the fan. And elastic potential energy, as I discussed with you the example of a rubber band, the rubber band is being stretched. There is a change in the configuration of the rubber band, and because of this change in the configuration of the rubber band, there is energy, potential energy, which is there in the rubber band, and that is known as elastic potential energy. Okay, so we'll focus on gravitational potential energy only. So gravitational potential energy, which has got a symbol U, it is the energy possessed by a body due to force of attraction of earth on it. So if a body is at some height, you take any object at some height from the ground level, so the energy possessed by that object at any point of time will be the potential energy, and that is how you define potential energy. Now let us talk about the derivation of potential energy. So in this derivation we have an object whose mass is m and it is kept on a ground level. Now we know that the weight of the object, that is the force of gravity with which it is being pulled by earth, is W is equals to m into g, where g is the force of gravity, m is the mass of the object. It is being taken to a height h by you. It means you did some work on this object by applying a force and you displaced it up till some height. So you did some work. So how much work you have done? You have done W is equals to force into displacement. W is equals to obviously the mass of the object, the weight of the object, that is m into g. And how much displacement you did? You did h displacement by taking the object from the ground level to a height h. So how much work is being done by you? The work which is being done by you is mgh. So when you keep the object at some height, where will this work go? So this work will be stored in the form of potential energy in the body itself. So the work done by you is mgh, and the same work will become the potential energy, of the object. So the potential energy of the object will be mgh. Why mgh? Because the work done by you is mgh. Okay, so this is how you have to derive this expression for potential energy, and this is very important from your examination point of view as well. Now next is kinetic energy, whose symbol is K. So what is kinetic energy? So any object, when any object is moving or it is in motion, the energy possessed by that object due to its motion is known as kinetic energy. The symbol is K. So how to derive the expression for the kinetic energy? Let me tell you, the expression for kinetic energy is half mv square. So how to derive this? Where m is the mass of the object, v is the velocity of the object. Because of this velocity, the object possesses kinetic energy. K is the symbol for kinetic energy. So derivation of kinetic energy, we have a body of mass m who is moving with the initial velocity v. So what is the initial velocity of this object with which it is moving now? Is v. So the object is moving with an initial velocity v, object of mass m, and its final velocity became 0. So how does it become 0? You apply a force, this is the object which is moving with the velocity v, and you apply some force, and by application of this force, after applying this force, the velocity has come to rest. Okay, so when it has come to rest, its final velocity has become 0 after the application of the force. You have applied a force. How much force will you apply? The force applied by you will be F is equals to m into A, Newton's second law of motion. Now F is equals to ma. Obviously, you are applying some force on the object and you are stopping the object. So you have done some amount of work as well to stop the object. Okay, how much work you have done? Force into displacement. Actually, this work is done by this object. Initial velocity of the object is v, so object has displaced by s amount. So there is some work which is being done by the object. Okay, so w is equals to f into s. Now where will this work go? So when a force was being applied and the object has displaced s from its initial position, moving with initial velocity v, it has displaced from its position, and the work obviously is F into s, where F is the force which is being applied on the object. So where will this work go? This work will become the kinetic energy of the object. So how much kinetic energy? Same as the work which is being done. So if you apply a force on an object and the object displaces, so you basically, what you have done some work. So where does this work go? This work becomes the kinetic energy of the object. So the work has become the kinetic energy of the object. So that is why I have written, instead of W I have written K, which is force into displacement. Now retardation has been taken place. Why retardation has been taken place? Because you applied a force to stop the object. So initial velocity was v, final velocity is 0. So obviously the retardation is taking place. So retardation is negative acceleration minus a. We know this equation of motion, v square minus u square is equals to 2as. V means final velocity. So how much is the final velocity? 0. 0 square minus u. What is u here in this expression? In this equation of motion, u means initial velocity. How much is the initial velocity? V. So it becomes v square minus 2a. This negative has come because of this acceleration, which is the negative acceleration. So that is minus 2as. So it has become minus 2as is equals to v square. Negative goes off. S is equals to v square upon 2a. Now we know that this equation k is equals to f into s. So k is equals to f into s. Instead of s, we have substituted the value v square upon 2a. So v square upon 2a has come. So F is ma, which is the force being applied on this object, and that force, because this object has got mass m, does an acceleration of a and it moved like this. So F is ma, and this v square upon 2a as it is, this a goes off. What we are left with is mv square upon 2. So this is the expression for kinetic energy, and this is again a very important derivation as well of kinetic energy. So kinetic energy is half mv square, whereas the potential energy is u is equals to mgh. Thank you.